Hello, and welcome to my video here talking about t-tests. We're using the software, the SPSS by IBM. I am Seth Welton, and I will be your guide today. So, boop. So there are three different types of t-tests that we're going to talk about today. The one sample t-test, the independent samples t-test, and the paired samples t-test. So the purpose of the one sample t-test is that it is used to check to see if there's a difference between the group population. So I'm going to talk about that in a little bit. Actual differences between when you're looking at a group versus your population when you're using your t-test, your one sample t-test. We check to see if there are differences in the sample mean and the population mean. Whether so that your sample is something, the sample mean is what you're going to be coming up with in your hypothesis. Next. So I'll move my. Can I move my hat out of the way during the flip? That'd be sick. So the proposed question would be, so for the tests, that we're going to be doing today, my proposed question is, so we're going to look at a group. Okay, I'm putting these together. We're going to look at a group, and the group is going to tell us, at least give us an idea of average grocery shopping spending. So the proposed question is the average spending price at a grocery checkout about $100? So the population in this case, it could be everyone, it could be the United States, it could be in our state, Colorado, it could be in the city, it just depends on like your scope here. We really want to be testing out but for now, I mean, the population doesn't matter too much, but the group is what we have actual numbers for at the moment. So we took, I didn't do it, but in the sample, the number of samples in the data, the number of samples, so basically we tested 1,404 people in our proposed made up experiment here. Just calculating how many, like the checkout prices when people finish shopping. Using coupons, no coupons, doesn't matter. Just as long as it's the price that they paid at checkout. Okay. And so we tested 1,404 people. And that would be our group. So next is, so first we're going to have to establish two kinds of hypotheses for the single pair, whatever this is called. So the null hypothesis is kind of like, so our null hypothesis in this case is that the average spending in a grocery checkout is $100. So we're going to be testing this. We're going to be testing this against the $100 hypothesis. The average spending at grocery checkouts is $100 is our null hypothesis. So we call it the H0, which is, or the mu. So our H0 is the null hypothesis, and our mu, which is our sample size. So it's going to be like our base level, our base thingy. We're going to be testing it. So we're going to be testing $100. Is $100 the middle ground, the mean of our sample data? Like on average, is it $100? So our alternative hypothesis is going to be the opposite of that. So that's going to be our H1, where our mu is it's not $100. The mean is not $100. It's just something else. And that's our alternative hypothesis. So the average spending at grocery checkouts is not $100 for the alternative hypothesis. I just repeated myself, but that's okay. Here we go. So when we're using the SPSS, we are going to be using, we want to open up our data first. So first we're going to go to File, Open, File, Open, and then go to Data over there. And all the way over there, you want to look at grocery coupons. So this file and the other files in this video will be inside the immediate directory next to the slides and stuff, the slides and the video link and whatever. So it'll be there. You can also get these samples from when you download SPSS. It comes with a bunch of sample videos, sample data sets that you can kind of use. So then, for our case, it's right there in that folder. So wherever you downloaded it, go get it. grocery coupons. That's CSV, and then you'll see something like this pop up. So we are going to look at just the right, which is my left, the rightmost column about the amount spent. We're going to be testing that data right there, all the way to the right. So the nice part about the one sample test is that there's really only one data set you need. Just one data set, just a bunch of samples put together, mash them together, mash them. What is it? Mash them, put them in a stew.
Boil them, mash them, stick them in a stew.
Gotta hear that. Okay, I'm putting that in here. Okay, so now that we have our data loaded up in SPSS, we are going to go to Analyze, Compare Means and Proportions, and the One Sample T-Test. So that'll pop up a new window, and then you'll see all of the columns over there. See all the columns over there. And so we're just going to go look for amount spent. We're going to click on it, click the little arrow doodad right in the middle of the screen, and it's going to pop up right here into the left, into the right side for test variables. So the test value that we want, which is our mu, which was and our null hypothesis, because that's what we're going to be testing against. So 100 is going to be what we're looking for. That in the test value where that little red box is, and then we'll select OK, and then bam, we got lots of data. We got lots of data to look at. Okay, so if we look at the in value up there, that is the number of samples we had, which is 1,404 samples. That is the mean of our samples, which is 99.9, which is ridiculously close to 100, which was our test value. The standard deviation, that is, so if you think about the graph, the mean line, right? The standard deviation means that with the dots surrounding the line, which are our samples, the deviation, like it's telling you how far it deviates from the line. So like 48, like it deviates about $48 plus or minus 100, right? And then the standard error mean is just how much of a possible error the standard deviation could have. So we have our t value right there, which is negative 0.51. It being positive or negative doesn't matter. We're going to end up absolute valuing it. What it means is that our mean value is less than, our mean value in the sample is less than the mean value that we tested, which is 100. And it is. Look, the mean value for the rest of them is 99.9, right? So, which is less than 100, which is great. So that's all that means. So DF is the degrees of freedom, which is just our sample size number, which is 1,404 from the in, all the way up there, minus 1. We use the degrees of freedom to be able to look at the table that we're about to see in a minute. So over there we have the significance level, that way. The significance level between the one-sided P and the two-sided P. We're going to be focusing on the two-sided P because our mu for our null hypothesis is asking, our null hypothesis and our alternative hypothesis, they're both asking, is it equal to 100 or is it not equal to 100? So it's good when you want to detect any kind of difference. The one-sided P is when you is if your hypothesis is asking, is it less than 100? Is the mean value less than 100, or is it more than 100, so it's asking for one side of it, not any kind of difference. So it's best when you're specifically interested in a specific direction. So since our hypothesis is saying that we want to know if it is or if it's not equal to 100, we're going to stick with the two-sided P. So anyway, the mean difference, that's the difference in our mean. It maths up from the actual mean up there. So the mean 99.9, and then our mean difference being negative 0.06 is just saying the difference in mean. I guess it's self-explanatory. Okay, so then the last part we're going to talk about is the 95% confidence interval all the way over there. It being -2 and 2 will matter in a minute. But, okay, so let's get into more detail here. All right, so for the t value, which was the one all the way to the left, our t value was -0.051, which what we do is we look at a critical value table, which is what this is, and we check based off of our degrees of freedom, which if you look on the left, if you look all the way to the left there, you can see that the DF, our DF is 1,000, so it's pretty high, but it is still on the table, so we're good. So 1,400, whatever. So what we do is we want the 95% confidence level, which is what over here, back here, this is what we have, the 95% confidence interval difference, right? So at the very bottom, it'll say the 95% confidence level. Gotta get used to this. 95% confidence level. We look at that column, and then based off of our degrees of freedom, we are looking for a value of 1.962. And so what we do is we compare our t value with that, which our value is 0.051, which is less than 1.962, which would indicate that we accept our null hypothesis, which was that there is no statistical difference between, no significant statistical difference between our hypothesized mean, which was 100, and our other mean, our sample mean, which was 99.9. Like, there's no big difference. Pretty much hit it on the money right here. Okay, then we are going to go to the p-value, which was the next one. Right here, we have, we're looking for if the statistical significance, which is our p-value, is less than 0.05. A lot of scientific societies and organizations usually use 0.05 as a good baseline for a p-value. So what we're looking for is if the p-value is less than 0.05, we're gonna accept the null hypothesis, and if the p-value is greater than it, we're gonna reject the null hypothesis. In our case, our p-value is our p-value right there for the two-sided p is 0.959, which is definitely bigger than 0.05. So, which indicates that we accept the null hypothesis, which was what the other one said. So the t-value is saying we accept the null hypothesis. The p-value is also saying we accept the null hypothesis. And then the last part we can use to also verify that this is not statistically different is the 95% confidence level again. Now we look at the lower versus the higher. Oh, my face is in the way. Hang on. I'm going to put me here. So there's a 95% confidence interval, right? So we're looking at the negative versus the positive. So the lower being negative and the upper being positive means we crossed 0. So since we crossed 0, it suggests that the true difference could be 0. There could be no difference, possibly, right, between the sample mean and the hypothesized mean. So this indicates that there's not enough evidence to support that there is a significant difference between the sample mean and the hypothesized mean, which is our mu, which is 100, which thirdly, indicates that we should accept the null hypothesis. Because there could be no difference. That's the point. But there is a difference. But like, it's just saying that there's a possibility that we're good. So those are the 3 ways that you can check to see if you want to reject or accept your null hypothesis. And that is the one-sided T. Why can't I control this? Not the one-sided. The that is the. Dang it! What is this called? One sample test. Okay. So that was the one sample test. So now we're going to look into the independent samples t-test. Okay, so our independent samples t-test, I'm going to move me over here. The independent samples t-test, so the purpose of this is it's used to check if there is a difference between 2 groups within a population, right? So the face is getting darker. Oh well. So this is used to check between 2 groups. So we check to see if there's a statistically significant difference between 2 sample means instead of a hypothesized mean and 1 sample. So we have 2 samples. So it checks if surface observations between groups are real differences or if it's due to just random variance. Really important. Make sure you check that out. I'm going to go turn the light on. A little better. Not much better, but it's a little better. Anyway, so we're doing that. So I'm going to move me here. So here's the proposed question. Is there a difference in average salary between men and women? So we're going to just look in this small data set to do a little statistics. So our one group will be men and one group will be women. So our null hypothesis is that there is no statistical difference between there's no statistical difference in average salary between men and women. And then our alternative hypothesis is our H1, which is that there is a statistical difference in average salary between men and women. So we are going to use SPSS some more. So same drill as before. We're going to, he's always backward, go over there, the file, open, go to the data again, get the data from the same directory as these slides, or from the download if you downloaded SPSS. Or I mean, you can also look there, is what I'm saying. Then you will get this data when we select the employee data SAV. So in this data, we're going to be looking at, I didn't highlight it. There's a salary column right in the middle. Right over there. Oh, there it is. Okay. So I did highlight it. Good. Past Seth was smart. So anyway, so we have 2 columns. One is based off of gender, and the other is based off of salaries. What we're going to do is go to Analyze. Wow, I can't do this. There we go. Go to Analyze, compare means and proportions, and do the independent samples t-test. Then we're going to, this window is going to pop up right up here. What we're going to do is we're going to find our 2 columns, which are gender and current salary. So if you look at the thing right here, look at the one right here. If you click on the arrow, the top sushi arrow, and right in the middle, and with the current salary highlighted, you'll move it over to test variables. So any of the variables you want to test, you put it in there, like your data set. And then the grouping variable, it doesn't know what to do yet. So first you put gender into the grouping variable because you want to know if it's between men and women, and then their salaries are going to go in the test variable. How's that? Okay. That's what that. So right now, it doesn't know what it's doing. So we're going to have to click the Define Groups button, as demonstrated by the first one up there. Boop, boop, boop. You click the Define Groups, then we're going to end up over here. In this new dialog box that's going to pop up, and you want to say how is it labeled. You want to tell the SPSS how your two groups are labeled so that it can know what to look for. So if I put myself over here, so you look at ours are categorized instead of like 0. Sometimes it's categorized as like 0 or 1. Here we have M, F, male, female, right? So we're just telling it in group 1 over there, to group it by M and F. So then we're going to click continue, and then now it knows what's going on. And then after that, we're going to get the dialog will go away, and we'll end up with this. And then we're going to click the OK button. And then I'm going to move myself over here. All right, so we're going to get a similar data table as the one sample test. So our independent samples are for men and women. Over there, we got in, which is our number of samples again, the mean, the standard deviation. So the mean for both men and women seem to be really high, like really different, like 26 versus 41,000. Sorry, 26,000 versus 41,000 is a ridiculously huge gap for a mean. So our standard deviation for both of them are indicated there. The standard deviation for the men apparently is just gigantic, while the standard deviation for the women it's not too terribly different from the mean. So interesting. The standard error mean for each one is it's going to be bigger the more standard deviation you have. Okay, so that does indicate something. Well, I can think about this. Oh, there's so in my head here. Right. Oh, that means there's more outliers. Yes. Okay. Ow! Ow! So, the standard deviation for men being 19,000, so the gap is pretty big for it being different on the mean line, right? So that means that there's a lot more outliers. So some people are being paid a lot, or a lot little, or a lot less in either direction. The pay difference is a lot more wild for the men than the women, in proportion with the mean anyway. So we'll move on down here. The 11 test for equality of variances. We don't have to worry about that too much. We're just going to stick with the 3 things we did last time, which are the t-value, the two-sided p, because we're asking again, is it or is it not, instead of the one-sided p. And the last one, which is the lower and the upper, whether it crosses 0 or not. So, if you look at the t-value, man, that's huge. That's a really big t-value. The significance for the two-sided p is so small that we had to double-click it twice. You have to double click it twice to be able to get the actual kind of value, which is negative. Which is 5.3 x 10 to the negative 25, which is a ridiculously small number. Yeah, so it's so small that's just like, yes, it's smaller than p, or it's small enough that you don't really need to know unless you really want to know. That's why it shortcuts at that. So the mean difference there, yep. So that's the mean difference, which is the difference between 26,000 and 41,000, right? About 15,000, makes sense. And then our lower and upper, which we're going to talk about more in a minute. So let's get to it. To the t value. Then I got to move myself some more. Whee! So the t value here is negative 10.9, which is gigantic. So we absolute value it. We get 10.945. And then we look at our table over there. Our table is saying, so we're in the 100s, right? Because our degrees of freedom, got it. Our degrees of freedom would be, okay. The degrees of freedom are from like 258 and 216, so we're just going to check the 100 because it's way closer than 1,000. Anyway, so we look on that. We look in there in the same column because we're looking at 95% confidence level. We get 1.984. So with that in mind, we look up here. We compare it, and it is definitely way greater, which indicates that we reject our null hypothesis. Now, if you remember, our null hypothesis is that there is no difference between men and women in their salaries. So we're going to reject that based off of just this. And it seems pretty obvious even from like this part where we look at the difference in the means. Just looking at the means, 15,000 is probably a big difference. So anyway, continuing on. So we go here, and I gotta move myself some more. Whoop. We look at the statistical significance again. P-value is less than 0.05. We say we check if it's less, if we accept it. If it's greater than it, we reject it. So our value is 5.3x, our p-value, which is by the probability value, which it's 5.3x 10 to the negative 25, which is way smaller than 0.05. So here, looking at just the p-value, we also reject the null hypothesis. And lastly, we're going to see if it crosses 0. So here, both values are positive. So since they're both positive, we know that it's like over here, or I guess over here, right? Over here, if the 0 is like here, way over here. So we don't cross 0 from the lower or the higher, which means that the confidence interval does not cross 0, which suggests that the true difference is not 0. It's definitely not 0. There's definitely a difference. This indicates that there is enough evidence to support that there is a significant difference between two sample means, which also indicates that we should reject the null hypothesis. So all three things, which they will, tell you that we're going to reject this null hypothesis. There is a difference, according to this sample, that there is a big difference in salaries between men and women, according to this sample. There are these samples. All right. Then we're going to go on to the next thing. Okay, so now we're on to the paired samples t-tests. The purpose of this is it is used to check if there's a difference between two measurements of the same group. So we check if there are statistically significant differences in the sample means of like before and after a treatment or some kind of procedure or whatever. So that's kind of like the main purpose of the paired samples t-test. So again, just like the other one, just like the independent test, it checks if surface observations between groups are real differences or if it's just based off random variance. So, where do I even go here? I'll go here. I'll be this other guy. So So now the question for this one is there a difference in weight of our workout group before and after 4 weeks of pump and iron? So our one group is just a single workout group. They're not separated. So it's just going to show before they pumped iron and after they pumped iron. But after checking the age range of this data set, instead of this really focused looking guy, it's probably going to be more like these guys. So, our null hypothesis here is that there is no statistical difference in average weight loss after the 4 weeks. Dang. There we go. All right, it is updated. We now have the null hypothesis is now there is no statistical difference in average weight loss after 4 weeks of the workout program. And our alternative hypothesis is that there is a statistical difference in average weight loss after 4 weeks of the workout program. Okay, boop, boop, boop. Here I go here. So, to use the SPSS software, we are going to do it again. We're going to go to File, Open Data. Once again, we're going to open up the Diet Study SAV file, and we're going to get this data set right here. We worked the first time. Thank you. Move me over here. Sure. So these are the two columns we're going to look for. So this is the first one. The first one down there is our weight loss. Oh, sorry, is our original weight before we start working out, and the other column is after the 4 weeks. I'm making an assumption that it's 4 weeks because it looks like it would be about 4 weeks of working out based off the data set. The data set doesn't tell me, but just for demonstration purposes, it's fine. And I put myself here. Okay, so once we have our data set up, we're gonna go up to Analyze, compare means and proportions, paired samples t-tests. Then we're gonna go up there, and we're going to see the dialog box pop up. We want to put in weight 0, or just the weight, and the final weight, which would be the 4th week weight. And then we'll end up with those sitting in here. Once you place them in there, then we're going to press the OK button. And ShamWow, we have our data. Okay, so once again, we're going to look over there to our weight mean of before and after. Just by looking at that, hey, look, the group lost 8 pounds. Pretty cool, based off the mean. Then the number of our participants is 16 people. We have our standard deviation, which isn't straying too terribly far off of the mean line, so 33 pounds both ways. Standard error mean, there it is, and then we look down there. Look down there. I don't know if I just did that. There, down there. We see in again. So the correlation coefficient here is it measures the strength and direction between the two variables, are before and after. So basically, yeah, it's before and after. The correlation coefficient of 0.996 indicates that it is really strong, the super strong relationship between the weights before and after, which means that our workout, probably has to do with the weight change. So since the coefficient is positive, we indicate a positive relationship, which is, weight lost in this case. So it's positive number, but yes, we're losing weight. And then it's also, since it's super close to 1, it signifies it's almost a near perfect relationship between the two, implying that basically everybody in the set pretty much lost weight. So they did a good job. The workout group did a fantastic job. And yeah, that's what that pretty much means. So, after we look at that correlation number down there, next to it is our significance numbers again. They're super tiny. Then we look down here. We can see our mean, our standard deviation. It kind of repeats some stuff. The error mean, the confidence level again, the t-value, our DF, I keep forgetting what it's called, and then we have the significance again. But to check if it crossed between 0 or not, and that one's really tiny for some reason. Or, I'm sorry. The significance level is the p-value. It's just messing with me. So over here is the p-value, and then over here is the we check if we cross 0 or not. So let's do it again, shall we? Our t-value today is 11.175. We look at our chart. We say, okay, we have 16 samples for our 16 samples. Oh, I'm in the way, aren't I? Yes, I am. So we look over there. 16 samples, and then our 95% confidence interval, we ended up with 2.120. Our t-value is way bigger, so we indicate that we reject our null hypothesis. And remember that our null hypothesis is that after the 4 weeks, there was no real change in weight. Either way. Gaining weight or losing weight in our workout routine, yes. But so we're rejecting that, which means we're saying that there was a difference. Now, we look at our p-value. P-value if it's less than 0.05 as usual. So we look at our number. Our number is really tiny. Our tiny number is definitely less than 0.05, so we reject null hypothesis here as well. And then our last thing we do is the confidence interval, checking if it crossed 0. Both numbers are positive, so they did not cross 0, which suggests that the true difference is not 0 again, just like the last test. This indicates that there's not enough evidence to support that there is a significant difference between... This indicates that there is enough evidence to support that there is a significant difference between the two samples, which there is. And finally, we're going to have another thing to tell us that we're going to reject the null hypothesis. So, yeah, the workout guys and gals did great. They worked out good. Their diet was good. Good stuff. All right. So, after doing all 3 of our tests, after doing all 3 tests, based on our samples, for the 1 sample t-test, the average spending at grocery checkouts is $100. Based off of our samples, we accept our null hypothesis. For the independent samples t-tests, we're checking if there was no statistical difference in average salary between men and women. We found that to be false, so we rejected the null hypothesis. The paired samples t-test, we were looking to see if there was no statistical difference in average weight loss after 4 weeks of the workout program, and we found that we are rejecting that null hypothesis, which means that they did. It worked out good. They lost the weight. So, thank you very much for watching. This was very fun to put together, and I learned a lot, and I hope you learned a lot too. Bye!